In this video, we're going to be taking a look at Substance Painter for the first time. So Substance Painter is a program that is used for texture painting our 3D models. Generally, that is what it's used for. It also has a couple other use cases, but for the most part is the program where we will be doing our texturing. Now, before we jump into Substance Painter, let's first create a model that we're going to be painting on today. So briefly, before we go into Substance Painter, let's just create a normal cube, like so, inside of Maya, and let's say that this cube is the model that we want to paint. So first of all, whenever we work with Substance Painter, we have to be sure that we have UVs on our character or our model or any object that we are going to be working on. By default, the default shapes inside of Maya already have UVs ready. So if we go to the UV editing tab, we can see that we already have UVs on this model. So for now, the only thing that we're going to do is we are going to be exporting our model. So File, Export Selection, and export it wherever you want. I'm just going to name it Cube and export it. Now let's jump right into Substance Painter. Now, how are we going to work inside of Substance Painter is by creating a new Substance Painter file and assigning a model that we're going to paint to that Substance Painter file. So for starters, let's go to File and let's go to New, or alternatively we can click on Control and N to create a new project. When this window pops up, we can start to create our project inside of Substance Painter. The first option, the template, is not that important right now, but it is what we're going to use, what we're going to be using later on to set the template from which we're going to be exporting our textures. For example, if we're going to be working with Unreal Engine, we should be using the Unreal Engine for starter assets. If we are going to be working with V-Ray, we should use the V-Ray. Unity, we should use the Unity, and so on and so on. So for now, it doesn't really matter. The most generic one is the PBR Metallic Roughness. So let's just click on PBR Roughness and Metallic. This is most commonly used with every single software. So if you work with the PBR Roughness Metallic workflow, almost every program will allow you to use the exported textures. The second option is the file. So in the file tab, we can click on Select and we can select our cube. So for now, let's just click on the cube FBX and click on OK. Now we assigned which model we want to paint. Next up is the document resolution. By default, it's on 1K, but we can always change that up. For starters, we're going to be working with 2K resolution. Most of the time, we're going to be working with 2K resolution, but this doesn't really matter where we start from, because afterwards we can always change it. So if we want to assign 4K textures to our model, or want to export it to maybe 4K or even 8K, we can always do that. So this is just a starting point of your resolution. Same with the template, we can always change up the template that we want to export later on. The other options, so normal map format and compute tangent space per fragment, are not that important right now. Most of the time they're going to change accordingly to your template. So for now, just leave them as they are. The UV-tile workflow, we will work on that a little bit later. And right below that, we have the import cameras and the auto unwrap. So if for some reason we don't have any UVs on our character, we can use the automatic unwrapping inside of Substance Painter. It is not the best auto unwrapping method, but it still gets the job done if we want to unwrap something very quickly and maybe do a test bake or just test out how our character or model will look like painted. But 99% of the time you do want to have manually created UV maps to get the best result you can get. Now all we need to do is click on OK, and we should see our cube inside of Substance Painter. Now, the way that we navigate around in Substance Painter is the same way we navigate inside of Maya. So Alt and left click will rotate the camera, Alt and right click will zoom in and zoom out, and Alt and middle click will pan the viewport. So in general, it's the same navigation as in Maya. F is for focus, so we can focus up on the model, and so on. Now, another thing that we can do inside of Substance Painter is change the lighting. Whenever we look at a model inside of Substance Painter, it's already semi-rendered, so it's not fully rendered, but it's still affected by lighting. So if we hold down Shift and move the right mouse button on the sides of the scene, we can change the position of the HDRI or the environment and the lights in our scene. So for example, if we, let's say, want to paint this side, we can change the lighting to affect that side, and let's say want to continue texturing the other side, we can switch the lighting to that side as well. Now, a couple more shortcuts that are going to be very useful inside of Substance Painter. First of all, we have three main views inside of Substance Painter. So we have F1, which is both the 3D model view on the left side and the UV map view on the right side. So we have the 3D view and the 2D view mode one by each other. So F1 will open up both of our panels. F2 will only open up our model, and we can see our painted model solo, and F3 is just viewing the UV map. For starters, we're going to be working in the F1 viewport, or both the 3D and the 2D viewport, so we can cleanly look at what's going on. First of all, how do we work inside of Substance Painter? Substance Painter is a lot similar like Photoshop. So if anybody's worked with Photoshop, it should be quite similar workflows. Basically, Substance Painter works with layers. So it's a layer-based system, which means that we have layers one on top of each other, and they create textures that we can then export and use them with other 3D softwares. For now, let's just try and add a new material to this cube. So we can drag and drop the first one from the asset library, this aluminum, like this, and we can see that it instantly textures our model. So we have a material assigned to our model. We can see on the right side we also have the layer, so aluminum insulator. Materials are basically just fill layers with different properties and such, like so. Now, when we add the material, so the aluminum, we can see that it automatically adds details to our model. So not only that it adds color to our model, but it also adds bump mapping or normal mapping. It also adds roughness and metallic values, and so on and so on. So what are these values exactly? Now, first of all, let's go through the most basic maps inside of Substance Painter, and generally with other softwares as well. So if we click on this base color right here, we can see that we have 5 basic maps. That's the base color, height, roughness, metallic, and normal. Let's just go through all of these very briefly, and we can continue working on our cube. For now, let's just add a let's just see what this material has inside of it. So this material has a color map It has a height map, it has a roughness map, and it has a metallic map. We can also view these maps by going to the material, and on the drop down we can see that we have base color, height, roughness, metallic, and normal. Now let's look at them one by one. Base color is basically self-explanatory. If we click on the base color, we can see what color our model is. So the base color basically just gives color to our character or model or prop or whatever it is. The base color is very self-explanatory, and it's most likely the most important map of our character. Next up is the height map. Now, the height map is a black and white value map that basically adds detail to our character, like bumps, or something that is indented, something that is sculpted, and so on. So without the height map, let's go back to the material view for now. Without the height map, our cube would look extremely flat. So we can see that our cube will look extremely flat. With the height map, we can see that it adds detail to the character or to the prop, and it looks like it has bumps and dents. Now, all of these details are fake details, as we would like to say them, so they are not, it's not actually deforming the topology, and it's not adding extra geometry to create those shapes, but it's a trick, basically a trick that allows the lighting to have a different effect on different areas on the model. Now, if we go back to the height map, we can see that it's only a black and white mask, or it has only black and white values. That means that all of the white values are a little bit sculpted up or heightened from the basic mesh, like so. Now, the next one is the roughness map. So if we click on the roughness map, we can see that it's also a black and white mask, but this time it affects how much of the of our character is reflective. So if we click on the roughness map, let's go back to the material. Now let's just remove the roughness map. Now we can see that, let's remove the height map as well for now. We can see that the material is a lot flatter. Now, without the height map, it doesn't have any of those details, but with the roughness map, we can see that some of the parts on our model are a lot more shiny than they are on some other parts. So the black parts are a lot less shiny, or they are matte finished, than they are than the orange parts. This is due to the roughness map. So as we can see in the roughness map, the whiter the roughness is, the more matte finished it is. The blacker the map is, or the more gray the map is, the more shiny finished our model will be. Next up is the metallic map. Most of the time, metallic maps will be either fully black or fully white. Now, this is because in real life, a material or anything of that sort, a model, can only either be made of metal or not made of metal. So we do have the artistic freedom to maybe add a little bit of metallic to our characters, but if we want to make hyper-realistic models and characters, when we use the metallic map, we always want to have a full black value or a full white value. Now, the metallic map basically does that. So it assigns a black and white mask to what part of the model is made of metal and what part of the model is not made from metal. Now, the last one, the normal map, right now we can see that it does not have a normal map, so we only have a checkerboard. That is because the normal map inside our model is disabled. Let's go back to the material and try to enable the normal map. We can see that with enabling the normal map, it added a lot more detail and height to our character or the model. So we can see that without the normal map, it still looks like it has some bumps and dents, but when we add the normal map, it's a lot sharper and a lot more stronger in detail. All of these details are the same as before. They are flat, so they are not deforming the geometry or not subdividing and adding extra geometry on top of our model, but just adding fake shadowing to our character, just so it can look like it has a lot more detail than it actually does. Now, if we look at our model from the side, we can see that it is completely flat. So normal maps are not that good if you look at your character from the side, but if we look at our character model from the front, we can see that it really does give the illusion that something is sculpted upwards or something is indented into the model. Now, if we look at the normal map, it might be a little bit tricky to understand at first, but what it basically does is it has a RG and B channel. So it has a red, green, and blue channel, which basically is assigned to how the lighting from the scene will affect our model. So if we go to the normal map, we can see that some parts of our character are red, some parts of our model are blue, and that basically tells the software how to assign the maybe the glossiness of the character, the shadowing of the character, and so on. So basically, the normal and height map are the two maps that add a bump mapping or height mapping to our model. These are the maps that add a lot more detail to our model. We can see we can learn about baking in a few classes, I think next class, and we can see how we can create our own normal maps through sculpting and other methods. For now, those are the 5 basic channels of inside of Substance Painter. So we have the base color, we have the height, roughness, metallic, and we have the normal map. Let's go back to the material and let's right now delete the material. So let's click on the material and click on the delete button to delete the current material. So as we said, materials are basically just layers inside of Substance Painter. Now we're going to be learning about the basics of Substance Painter, and the 2 basic parts of Substance Painter are fill layers and paint layers. Now in the layers tab right here, we can see that we have 2 different layers. So we have a paint layer or just a normal layer, and we have a fill layer. Let's see what the difference between the 2 layers are. So first of all, let's add a normal layer to our model, like so. And with this paint layer, we can see that we can start drawing on our character. We have a little paintbrush that we can start drawing on our character. Now, when we try to draw anything, we can see that nothing is going to happen on our model. That is because if we scroll down to the paint layer, we can see that we have color, height, roughness, metallic, and normal values that we need to paint on our character. To paint on our character, we need to go to the paint brush, or a shortcut for that is also 1. So if we click on 1, we can see that now the options of the color, height, roughness, metallic, and normal will open up. And now we can start to paint on our model. Whatever we have selected here, so let's say the base color, if we get a red color, we are going to be painting with a red color on our model. If we use, let's say, a blue color, we are going to be painting a blue color on our model. Same goes with, let's say, the height. If we, let's say, increase the height to maybe something like 0.8, if we start to paint with a height map now, we can see that it also adds a height map to our model. Same with the roughness. So let's say we add a much higher roughness, maybe something like 1. We can see that it is a lot rougher than it is on the sides, like so. Now let's reset these. So 0 and 0.3 3 on the height and roughness. And let's delete this paint layer for now. Now let's add a fill layer. So if we add a fill layer, we can see that by default nothing happens. That is because we need to change, the same as the paint layer, we need to change all of these values. Now, whenever we change a value in a paint layer, it will automatically affect the whole model. So for example, if I change the base color of a fill layer, we can see that the whole model is going to change in colors, like this. Same, for example, we cannot use the height map right now because it cannot add the illusion that something is sculpted upwards or something is higher than something else, because it basically affects the whole model. We can affect the roughness map. So if we play with the roughness map, we can see that if we go down to 0 roughness, it kind of looks like some sort of glass. So it's a lot more reflective and shiny. And if we increase the metallic value, we can see that it looks like it's made out of metal, like so. If you ever want to make a perfect mirror, you would need to select the metallic value to be 1, the roughness value to be 0, and the color to be white. This is how we create a perfect mirror inside of Substance Painter. Now, when we create this mirror inside of Substance Painter, we can see that we actually have some reflections going on from an environment. Now, if we hold on Shift and we move with the right mouse button, as we said before, to rotate our environment, we can see that the reflections are rotated as well. So how can we actually see this environment? By default, inside of Substance Painter, we already have an HDRI or an environment map inside of our viewport. So in the environment map, we see that right now we are using the panorama viewport, and we can see that we have a lot more options that we can maybe change. For example, we can maybe use this studio background, like so. We can maybe use something like a desert. So there are a lot more options. These will not affect your final model in any sort of way. So when you export textures, they won't affect your model or textures in any sort of way, but it's always good to use an environment map that is the closest to the one that you're going to be using in your scene. For example, if I know that my character is going to be in a forest, I will use a cave entry forest to paint my character. Now, this is a perfect mirror, so let's bring that back again. So maybe to roughness about 0.8. Now I can see that the environment map actually changes how it's going to light up my model. By default, it's using this panorama environment map, which will work good on most characters. So this is a basic generic map. Now, back to the fill and paint layers. What we're going to be doing now is creating a dice. So we have a cube model. So now let's create a dice on our character. For now, I want to create a background, or not background, but fill this model with a single solid color. I want to assign the roughness to be 1, so my model to be extremely matte and not have any reflections, and add a black color to my model. Whenever you add a black color to your models, you never want to have a full black color, because nothing in the real world is fully white and fully black. Everything is somewhere in between these two values. So let's add just a little bit of white to our color, and we can see that right now it doesn't really look like it's black at all. So it looks a lot more like it's grayish and not that black. But if we use the base color channel, we can see that if we go all the way down to black, our model is going to be completely black. If you go back to the material, we can see now that it's affected by the lighting in our scene, and that's why it's not completely black, as it would be inside of the base color single channel. So now that we have a base for our cube, let's create also a paint layer. Now, when we create the paint layer, we want to assign some options. So on the color, I want to paint with a white color, the same as before. We never want to go full the white, so just a little bit downwards, like so, and test out how it would look like on my model. So for starters, I also want to maybe indent this indent my number on the cube. So what I'm going to do is on the height value, I'm going to decrease it a little bit, maybe to something like 0.8, and click on my model again. Now I can see that it adds the illusion that my model is indented, but it's still not the result I am looking for. Well, first of all, we can see that whenever we click on our model, it has a sort of a opaque edge border, so it's not fully in focus. So if we click on it, we can see that it kind of fades towards the outer edges of our brush. Now, in the top shelf, we can see that we have mainly three different options. We have the size, we have the flow, and we have the stroke opacity. These are the three most important things for your brush strokes. Now, let's try to change some of these values. So if we try to change the size on our brush, we can see that it will also affect how big our brush stroke will be on our model. Now, if we click on 1 and we increase our brush a little bit, we can see that we can paint a lot bigger brush strokes onto our model. Now, the second option is the flow option. So if we, let's say we decrease the flow to maybe something like 20, we can see that the way we paint is a lot less opaque. So flow is basically opacity on our brush, or how opaque our brush strokes will be. If we just click once on our model, we can see that it will be a lot less opaque. But if we move around with the left mouse button a little bit, we can see that we can paint over it, and it will be almost completely opaque. Now, the stroke opacity works in a very similar way, but the only difference is that it's always going to be, let's say, at 20%, no matter how much we paint over it. The way we can increase the opacity, let's say, of our model is by painting once, then releasing our mouse button, and then painting over it again, like so. So the difference between the flow and the stroke opacity is that if we use the float at a lower value, we can just go over our model, and it will add opacity to the brush stroke. But if we use the stroke opacity option, we cannot add more than what we started with. Now, the buttons here for the right next to the size and the flow are if you're working with a tablet. So if you're working with a tablet, when you click on the pen pressure, the harder you press down with your pen, the bigger the size of the brush will be, and the same will be with the flow. So the harder you press down with the flow, the more opaque your brush stroke will be. Now, all of these can be also changed with shortcuts. So, for example, the size on our brush, we can also change by holding down Control and moving with the right mouse button, left and right. So whenever we move with the right mouse button, left and right, while holding down Control, we can change the size of our paintbrush. Alternatively, we can also use the control and right mouse button, but now instead of going left to right, we're going to be going up and down. If we go up and down, we can see that we can change the hardness of our brush. So if we scroll up in our paint properties, we can see that we have hardness on our brush. If we hold down control and right mouse button and drag down, we can see that we would have a lot less hardness on our brush stroke. If we increase the hardness to 1, we can see that it is fully opaque and not fading out to the sides. Now, for our specific case, we do want to have hardness on 1 for our brush strokes, because now for our specific case, we want the hardness of our brush to be at 1, because we want to paint numbers onto our model, like so. Now, let's get the appropriate size of our brush, maybe something like this. I think it looks fine. And assign also some properties. So height, let's go to maybe -1. Roughness, let's make it a lot more shiny, so maybe not 0, but something like 0.07. And let's start painting on our model. Now, what we can see right now is that whenever we paint on our model in the 3D viewport, we'll also see it live on the 2D viewport as well. So whatever you do on the 3D viewport, or vice versa, if you do anything on the 2D viewport, it will also translate to the 3D viewport as well, like so. Okay, so let's just create our cube right now. The top part is going to be 1, and the bottom part is going to be 6. So now it is time to create our dice. So the top part will be our 1. Maybe we can decrease the size just a little bit, something like this. The bottom part will be 6. So 1, 2, 3, 1, 2, and 3. And then we go to here, 3, the other side is 4, and the final side is 5, like so. Now, if for whatever reason, let's say this brush stroke, I don't like it, it's not centered well, and I want to erase it. Right below our paint button, we have the erase button as well, or a shortcut for that is 2. So we can always switch up between 1 and 2 to go between the erase and the paint mode. Now, let's increase our erase brush, and we can erase anything that we've painted onto our character. The good thing about both of these, the erase and the paint, is that they both hold their own properties. So if we use the paintbrush and we set, let's say, the size to 40, flow maybe to 42, stroke opacity to 58, if we change between the two brushes, we can see that it remembers all of our properties, like so.